Have you ever looked at a graph and wondered what function made it? Today we will learn how to recognize parent functions by the shape of their graphs and their features. Let's get started. So again, we're going to identify and describe parent functions and graph and identify the key features of those parent functions. So let's begin with the linear function. And a linear function is a straight line. Linear has the word line in it. That's how you can remember that. Now let's go on to number 2, a quadratic function. A quadratic function is U-shaped. And it is y equals x squared. See the U shape here? Number 3 is an exponential function. This shoots up really fast. For example, y equals 2 to the x power. Or it drops off super fast. For example, y equals 2 to the negative x power. Let's continue here. Number 4 is a logarithm. A logarithm is a very slow climb or a slow fall. And the function for a logarithm is y equals log of x. And number 5 is the absolute value function. And this is V-shaped. And the equation for the parent function is y equals the absolute value of x. Now we continue with the square root. The square root function starts at the origin and slowly curves upward when it's positive. When it's negative, it starts at the origin and curves downward. And number 7 is the cubic. And this is a very tall S. It kind of looks like a sideways S. And the function is y equals x cubed. Now the cube root is an S shape. If you look here, you can kind of see the S shape. And we continue with number 9 and 10. Number 9 is the sine function. And these are very smooth waves that repeat. And notice here, the sine goes through the origin at 0, 0. And number 10 is cosine. It looks similar to sine. It's a wave, but do you notice it goes through the point 0, 1 on the y-axis. And finally, number 11 is the tangent. These are broken waves. And they are steep repeating curves with gaps between them. So let's see how many you recognize. Now let's see how well you can recognize these graphs. Which graph looks like a straight road? Is it linear? Is it quadratic, exponential, or absolute value? Circle your answer. Number 2. Which type of function does this graph represent? Water spraying from a fountain that forms a curved path. Many bridges use a curved arch design. Roller coaster hills like at Cedar Point. Or the path of a basketball going through the hoop. Is that a linear, quadratic, or exponential function? Circle your answer. Okay, let's continue with number 3. What type of function does this graph represent? Household AC voltage is intentionally generated as a near perfect sine wave, 60 Hertz in the US. Or if a Ferris wheel spins at a steady speed, a rider's height goes up and down in a smooth repeating wave pattern. Electromagnetic waves used in radio transmission. Or the vertical or horizontal position of a point on the rim of a rotating wheel. Is that quadratic, cubic, or sine or cosine? Circle your answer. Now, let's do a little matching activity. Match the graph to the function, and you can draw a line to match the graphs to the functions. The options are a cubic function, a square root function, the absolute value function, logarithm function, or tangent function. And finally, it's time for a quick challenge. What is the parent function? Try to identify the function as fast as you can. Explored 11 different parent functions and we learned how to recognize them by their graphs. Remember the key ideas. Linear looks like a line. Quadratic looks like a bowl or a U. Exponential is kind of like a rocket curve. Logarithmic is a slow climb. Absolute value starts with V and it's a V-shaped. The square root. And we also talked about the cubic, kind of looks like a tall S, sideways, and a tall S, and the cube root looks like a wide S, and then the sine function looks like waves going through the origin 0, 0. And the cosine is a wave that intersects at 0, 1 on the y-axis. So do you remember the shape? Once you do, you'll be able to recognize the function. Keep practicing, keep exploring, and keep enjoying math. And see you next time.
And that's why math is so fun, because it's everywhere, making the impossible possible. Enjoyed the video? Like, share, and subscribe for more.